Hello students and welcome to Edupedia World. My name is Shivam Mishra and today we are going to discuss the solutions to IIT JEE Advanced 2015 paper 2. Okay students, let us look at question number 1. It says that in dilute aqueous sulfuric acid, the complex diaquo dioxylato ferrate 2 is oxidized by MnO4 minus. For this reaction, the ratio of rate of change of H plus to the ratio of rate of change of MnO4 minus is. Now this is an integer answer type question and it is based upon concepts from multiple chapters. First of all, from kinetics we can say that we have to calculate the ratio of rate of change of H plus to the ratio of rate of change of MnO4 minus. So basically we need a balanced chemical equation for that. The ratio of rates will be the same as the ratio of stoichiometric coefficients. Secondly, you must also know the products of an inorganic reaction in the case of oxidation and reduction. And thirdly, you must also be able to write the formula of the complex from the name. That is, you must have an idea about coordination compounds. Okay, so let us take it one by one. The first thing which I am going to do is going to write this complex for you. It says diaquo dioxylato ferrate 2. So obviously Fe is going to be there in +2 state. Diaquo would mean two H2O molecules acting as ligand, so it would give you H2O whole twice. Dioxylato would mean C2O4 whole twice, and this would be my complex. All right, and iron is in +2 and oxalate is a bidentate ligand, so coordination number would be 6, makes sense. And C2O4 2 minus would be a total charge of -4 and Fe would be +2, so that would give a charge of -2 on the overall coordination sphere. And then we have MnO4 minus, okay, in acidic medium. Now what are going to be the products of this reaction? The products would be, you need to know how each of these species will be oxidized. So your Fe will be oxidized to +2 to +3, all right, and oxalate will be oxidized to CO2. Fine, this will be the oxidation. And MnO4 minus in acidic medium, it will go to Mn +2. So these are my products, and now I'm going to balance this reaction. Now for the purpose of balancing, we first of all balance those atoms which are undergoing a change in oxidation state. Just for the purpose of clarity, I am just rubbing this out, the charges which I had initially written, because now I'm going to write the oxidation state. Okay, so Fe, as we all know, is in +2 oxidation state. Carbon in oxalate is in a +3 oxidation state. Carbon over here is in a +4 oxidation state. So we are going to balance those atoms which are going a change in oxidation state. So we can see 4 carbon here. I will make 4 CO2 over here. Okay. And MnO4 minus is going from +7 to +2. So clearly the valency factor for MnO4 minus, I'll write it separately over here. MnO4 minus going to Mn +2, this is a very standard case. In acidic medium, it goes from +7 to +2. So we can clearly see a change of 5. So valency factor would be 5 for this case. Now let's come to this compound. Fe is going from +2 to +3. So there is a change of 1. Carbon is going from +3 to +4. But there are a total of 4 carbon atoms. So there will be a total change of 4. 1 for Fe, so that makes it a total of 5. So clearly the valency factor for this complex is also 5 and MnO4 minus is also 5. So that means their ratio would be 1:1. Now we are only left with balancing oxygen and hydrogen. First of all, we balance oxygen. There are a total of 2 and 2 4s are 8. 8 and 2, 10 and 4, 14. 14 oxygen, and there are 4 2s are 8. 8 oxygen. There were 14. So 6 are missing. So I would add 6 H2O on this side. Fine. So 4 2s are 8 and 6 14, and this side also there are 14. And now we'll balance hydrogen. Hydrogen, if we come to, there are 6 2s are 12 hydrogen on this side and only 2 2s are 4 hydrogen. So that means we are going to add 8 H plus. This is my final overall balanced chemical equation. And now the ratio of rates will be the ratio of stoichiometric coefficients. The stoichiometric coefficient of H plus is 8, MnO4 minus is 1. So clearly the answer to this question would be 8:1, and it's an integer answer type question, so that would mean we can only write it as 8. Thank you.